All right, so this is pretty much the last slide that we looked at during our yesterday's in-person class, and it is going to be a little bit of a review of just to make sure that we covered all the bases, because this is important. Sound systems like this, which is distributed audio, excuse me, is going to be, well, for the most part, a bread and butter thing to uh, while you're installing things. All right, so that goes with just freestanding systems installations like this, or in conjunction with other systems such as telephone systems, because paging systems and telephone systems go hand in hand quite often, all right? Especially in the commercial situation. So let me just see if I can get this thing on here. All right. So what we see here is the signal path as such. Here is the input from whatever the device. It could be such a simple transducer as a microphone, or it could be some audio source such as music, or it could be a telephone system, and this would be for paging, or it could be a school PA system scenario, or any other public address situation that we have here. All right. So this goes into some sort of processing circuits, and this particular zone, notice that I said zone, is well, routed through an amplifier or an amplifier channel, because amplifiers can have more than one channel. So this is an output of an amplifier. Now, this, remember when we talked about the maximum power transfer, and in order to accomplish maximum power transfer for the signal, we have to have all the impedances match. So the output impedance of the amplifier, excuse me, has to match with whatever is plugged in to that channel, and then you have the most efficient way of transferring the signal. Now, what we have here is called a step-up transformer, because it steps up the impedance from, let's say, 8 ohms here. And that signal has to be delivered into the 8 ohms right here where the speaker is, or the loudspeaker. But in order to be able to connect it in a way that makes sense, and what I mean by that is the ease of installation, or the simplicity, or the practicality of installation. Remember when we could do a bunch of speakers and you can connect them in serious parallel combination, and yes, you can accomplish the required impedance to be plugged into the output of the amplifier. However, it's not a very practical solution when we're dealing with commercial installations, because sometimes we have multiple hallways and a lot of speakers that need to be connected to that. So the serious parallel situation would just be way too messy. Right? So then here's the constant voltage system has been established. What does it mean? It's a constant voltage system. Well, for the most part, we distinguish something that's called 25 volts or 70 volts systems. Right? Here is the line that goes all the way through, let's say, from one end of the hallway to another end of the hallway, okay? Excuse me. And well, it's one pair of conductors, so it's a cable consisting of one pair, usually 18 gauge, sometimes 14 gauge wire, all right? Stranded cable. Stranded conductor, stranded core, conductors made into one pair. Now, when the signal is at its full volume, let's say you put a sine wave through that, then the sine wave would be equal to 70 volts RMS across these two conductors at its full volume, if it were a 70-volt system. If it's a 25-volt system, then, of course, the constant voltage across the two pair would be 25 volts RMS. And why is it called constant voltage? It's because the voltage is common to all the speaker stations. So here's the main audio bus line. And we are tapping into that audio bus line with different speaker stations. Now, a speaker station consists of a loudspeaker mounted on a baffle. Could be rounded, could be square. Usually it's rounded. Or round, sorry. Then right beside the speaker or the loudspeaker, there is a step-down transformer, because the step-up transformer steps up the impedance from, let's say, 8 ohms on this side of the primary windings of the transformer, and it's converting the impedance to, or transforming the impedance to, let's say, something like 1200 ohms, 1600 ohms, in the range of that. And then we have the step-down transformers that are connected into the line in parallel. Just tap in, tap in, tap in, and keep going. And that step-down transformer transforms the impedance to the 8 ohms at the speaker's terminals. Now, you might notice some, wow, two things here. You see those dots? That's the beginning of the winding. The dot symbolizes or indicates the beginning of the winding, so the direction of the winding. Right? Now, here's the situation. Here's the deal. If you connect those speakers in an uncontrolled way, and what I mean by that is that sometimes the polarity would be as such, and maybe the other speaker would be connected with the reverse polarity. Are these going to work? Are they going to make sound? Yes, they're going to make sound, but is this a correct way of installation? No. Here's something that's called, the speakers have to be in phase. What does it mean that those speakers are in phase? Well, you have to have more than one speaker for that to accomplish in phase or out of phase signal happening. Okay. Well, if it's a positive cycle of the, let's say, sine wave or a signal, whatever the audio signal is, and let's say if the windings are connected in a way that during that positive cycle of the signal, the membrane of the speaker is going to push out. If this speaker is in phase with that one, both membranes are going to push out during the vibrations that they make sound. Now, if you connect them the opposite, yes, they're going to make sound, but if one is going to push, the other one is going to retract. So you're going to have out of phase motion with those two speakers. Well, what's going to happen? Some sound cancellation might happen, so you might not get as much volume as you want. But the other thing is going to happen is that they are going to sound like they are out of phase. And the closest thing that I can describe, and I know it's not very technical, but it's probably the most accurate. If you are listening to those speakers beside each other, they are going to sound, and this is not a very technical term, but I'm going to say they're going to sound weird, all right? And sometimes annoying, and you will not know why if you don't possess the knowledge of that, right? So what you need to do is you have to make sure that when you're connecting those speakers, they all have to be in phase. Now, also, there are certain taps. You see, here is the transformer, the primary winding of the step down transformer. Here's the beginning of the winding, or here's the beginning of the winding, right? Here's the common side. And this speaker station is tapped at something that's called 1 watt. This speaker station is tapped at 2 watts, and this speaker station is tapped at 1 watt. What does that mean? That means that at the full volume of the signal that is transmitted, well, is being pushed out from the output of the amplifier, if you accomplish a full volume of the signal, this speaker station is going to drain 1 watt of power, and it's going to reproduce that as a sound. Same thing here. Well, this one is going to drain 2 watts at its full volume. All right. Excuse me. Talking too much today. All right, so now also what you're going to see here is these two are just regular speakers with regular membrane, and this is a paging horn. Without getting into too much details, these would usually be mounted in the hallways, in the ceiling, or classroom stations. These would be mounted either on the outside or in large production halls. Because the sound from a paging horn, it doesn't have, well, this is not a hi-fi system anyways, but the sound coming from these loudspeakers is slightly better than the sound coming out of the paging horn. However, the paging horn has more cut-through power that can cut through noisy environment and so on. So in the production hall, you're not listening to hi-fi audio. You're not delighting yourself in some sort of, like, Pink Floyd The Wall and trying to get all the sounds that are coming out. No, these are strictly for announcements, mostly for announcements. Yeah? So the most important thing is that whatever is being said is understood and heard by the people who are in that building or outside. Okay? Well, I could talk all day about this, but this is as far as I'm going to get with explaining this type of a concept here. Now, before I switch to the next slide, also I'm going to mention, well, the power calculation that we need to do, and we already covered that, but let's just say that again. If this is a 100-watt amplifier and all the speakers are tapped at 1 watt, then, well, you could have hundreds of those speaker stations tapped into that one line. If they were tapped at half watt, those speakers, the speaker stations, well, then you could have 200 of those, and so on. So the power calculation is extremely simple when it comes to that. All right, let's get to the next slide here. Voltage, constant voltages and components. Here is the typical PA amplifier that, now let's see if I can zoom in here. All right, here's the output of this amplifier. Here's the common. So that's where, well, usually the black wire would go from that main audio line. Now you have different outputs here. This one has 4 ohms, 8 ohms, 16 ohms, and look, it has 70-volt output. So that's, this one here looks like it has a built-in transformer. That transformer right here, this transformer right here is built into that amplifier. It's inside that chassis. Right? Now, you can use regular commercial PA amplifiers. It doesn't have to be one of those. With just maybe 1 8-ohm output. Can you use that? Sure you can, but you have to buy an external step-up transformer, and you would just connect the primary The primary, do you like my new keyboard? It's kind of clicking, I love it. I got a new mechanical keyboard. So this primary winding of the transformer will be plugged into the output of the 8 ohm output of the amplifier, and you just continue with that, right? Mind you, these transformers come in various different power ratings. So you just got to make sure that the power that you require is established when you're buying or ordering that transformer. Some of them are as low as 10 watts, 20 watts, 25 watts, and they can go up to 100, 200 watts. Maybe sometimes, of course, they get bigger and heavier when, and transformers are, kind of bulky and heavy. However, they're wonderful devices and they're quite efficient. The efficiency of the power transfer of the transformer is in the range of 98%. Right. And just as a reminder, what do transformers transform? Transformers transform voltage, transformers transform current, and transformers transform impedance. Hence, there's the idea of something that's called impedance matching transformers. Well, these could be used as impedance matching transformer because look, it matches the impedance, the high impedance of that main bus line to the low impedance of that. So the impedances are transformed. What do transformers transfer or let through? Pretty much untouched is power. Right? So if the voltage increases depending on the number of winding ratios, if the ratios are 1-to-1, as far as number of windings, then the power transfer is going to be 1-to-1. Of course, always going to be 1-to-1, but the voltage is going to be the same on both sides. However, if the secondary windings of the transformer are half as much, so like say this one has 1,000 wounds, and this one has 500 wounds, so this is going to be 2-to-1 ratio. So the voltage is going to be, let's say, if we have 100 volts here, it's going to be 50 volts here. But in order to keep the power, because power goes through untouched, then of course the current has to be larger. Right? So that's just the basics of the transformers. Right? So we just covered the outputs of the PA amplifier, well, for the most part. And over here it's like a simple audio mixer functionality that you could have. You could have different channels plugged in. Over here, you can have different channels from the output. You can have different channel from the output, from the back side. You can have different channels plugged in, microphones or audio sources here. And these are the volume knobs for that. And you will have little tiny bit of tone control, highs or mids, like a low pass or high pass filter, just to kind of get the tone of the sounds to your liking. And here's the main volume control. So it's a pretty simple device as far as well, from the user point of view. Also, what I'm going to mention is that some amplifiers, and I don't see this one having it, they would have relay contacts here. And the purpose of that relay contact or dry contact. So you connect a relay from, let's say, the relay that is part of the telephone system. The purpose of that is to close the contacts for the channel, well, let's say the microphone or the audio channel to operate. Here's the thing. If you plug in, let's say, telephone system into one of the inputs, the designated input that is on that dry contact type of a system inside within the amplifier, and you have the volume selected to certain level, and then you have the main volume selected to certain level, adjusted to certain level, then electronic circuitry does have some noise. So you will hear some kind of a hiss or maybe some slight buzzes or whatnot. And that would be basically transmitted from the speakers all the time. And that would be annoying. So in order to remedy that, there would be a dry contact or relay input here to activate that input. So when the telephone system function is selected to do an audio page, then the audio output of the phone system gets activated and the relay closes on the phone system, and it closes the contacts on that amplifier to activate that input for that time of the page, audio page. And then when somebody hangs up and the page is done, then the relay releases and the input becomes inactive. So that's the, I don't see that functionality in this particular amplifier, but some of them do have that. All right. Now here's a typical 70-volt speaker station. What do we have? Here's the baffle. Right? And here is the loudspeaker, usually like an 8-inch. And here is the step-down transformer with secondary windings of the transformer connected, sorry about that, connected permanently to the 8-ohm terminals of the speaker. And over here you have one common and different taps that are going to be labeled as different power taps. And we already covered that. Also, what we have is something that it's a specific type of a volume control. And this is not just a regular potentiometer or variable resistor. This, on the other side of this, there is a transformer with different taps. So this here doesn't have a smooth action. It goes click, 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 just selecting different transformer taps. So you could, instead of connecting the speaker station straight to the line, you would be connecting that line into the volume control input terminals, and from the output of the secondary winding of the transformer that's at the back of this volume control, it would go to the speakers. You're putting that sort of like in line with this. So that's if somebody has some sort of a side office and just have one speaker in that office, they can control the volume of that one particular system. And it's made in a way that controlling the volume of that one speaker station is not going to affect the rest of the system, rest of the speakers. Okay? Now, this is a magnified version of the step-down transformer, and you can see, well, they're depending on who makes it, there are different configurations, right? So let's say there is, you can't see it, but this one says black wire. So the black wire will be the common, and you have different colors of wires that are tapped at different stages of the winding of the primary windings of the transformer. And they say orange is, that means it's a 2.5 watt tap. Then yellow would be 1. So that would be considered 1 watt tap, right? And so on, 10 watts, 5 watts, 2.5, 1.25. So for the purpose of simplicity, this would be called 1 watt tap, all right? Even though it says here that's 1.25 watts. Now, just as a general rule, if it's a school PA system, which consists of hallway speakers and classroom speakers, in order to accomplish a proper volume balance, if an all-call is made, an all-call page is made, then the speakers, the hallway speakers, would be tapped at 1 watt each, and the classroom stations would be tapped at quarter watt each. Then when an all-call page is made, you have proper volume balance. It sounds natural. Okay. Now, here's another look at the step-down transformer. See here those mounting holes that are mounted onto the speaker assembly. And here's, of course, the primary side of the transformer. Secondary would be just 2 wires, and they go into the 8-ohm terminals. And over here is just, see, black, common, red, 10 watts, 5 watts, blue, orange, 2.5, and so on here. Right? There's some more at the back there, maybe quarter watt, half watt, or well, this would be a half watt, considered to be a half watt. So sometimes you're going to see transformers like this. What do you use? You use just a black lead to go to the common, well, maybe a black lead of the main audio line, and you choose one of those to be connected to the other side, the other conductor of the main audio line. The other ones, you just cut off and blind them, sometimes with morettes or the wire nuts, sometimes with tape, just to make sure that nothing touches anything else by accident. Right? Some of the transformers, instead of having wires, they would have those spade taps, and you would have a spade connector, and you would connect, well, the secondary winding of the transformer was going to be permanently, well, soldered onto the terminals of the speaker, the loudspeaker. And you would use the tap connectors to tap into one of the common, and the other one, you would choose the proper tap in order to tap into one of those in order to accomplish the right amount of power that you need to be transferred into that loudspeaker. Okay. Here is a view of a volume control. You see, here's a transformer at the back. And its basic idea is the same as the step-down transformer on the speaker. It's just arranged a little bit different. So the user can select different taps of the transformer and then send different volume to the speaker. So you see here, hope you can see the mouse, my mouse. Over here, you would have those, well, primary side of this transformer, this input terminals, and here's the connector, and here is the connector right here. And you would connect this here to the main audio, just tap in to the plus and minus conductors for the signal. And over here at the other terminals, it's an output, and you would just connect that. This would be the secondary winding of the transformer. And it would go into the speaker station, primary transformer as well, primary windings of the transformer. So those windings are calculated, so you don't have to disconnect the transformer from the speaker station. You can just plug it in as it is. Yeah. And it's a typical 70 volt. Now, if you're using 70 volt output on the amplifier, you should have 70 volt speaker stations with the 70 volt transformer. Well, yeah, transformers. And if you use the volume control, you should use 70 volt volume control. If you use 25 volt system, then everything has to be specified for 25 volts. As far as mounting those, the back boxes or the device boxes for those transformers, the volume controls, make sure that you're going to use the deep boxes, not just the regular size. And it has to be specific because there's a bit of a bulkiness here, and you just got to make sure that the whole thing can fit into the box. All right, here's another view on the speaker station. Here is the step-down transformer. These two leads, there are two leads here permanently mounted onto the 8 ohms. They are not touched. And on the other side is the primary side of the transformer, primary winding of the transformer. And you're going to use only 2 of those leads, one common and whatever tap you want to use. Right? And you can read all that once you download this. It basically is more or less of what I've been talking about all along. Okay. I think this is the last slide. Whoa. I forgot to remove that sound. All right, just as far as mounting things on, because usually these speaker stations are being mounted onto the ceiling tiles. Those ceiling tiles, these are very soft material. You can just poke it with your finger hard enough and you're going to make a hole. So obviously, if you mount those speakers right just on that, with time they're going to sag, and they could just go right through the, they can fall down on somebody's head, and that would not be a good idea, right? So what is being used here is the framing of something that's called a dropped ceiling. with the ceiling tiles. So the main framing is quite sturdy. It's aluminum, but it can handle certain type of weight, such as the weight of the speaker station. And what is being used, different shapes of forms depending on the manufacturer. Here's an example of one. Here is the railing, the mounting railing. Same as those pot lights, for example, on this picture here. You can use also the mounting rails, and those mounting rails are just long enough to rest on the ledges of that aluminum framing. So the weight of the speaker is mounted onto the railing, and this here, you just cut the hole through the ceiling tile, and you're going to mount that speaker. So this would be on the top side of the ceiling tile here, and this baffle would be screwed into that railing from the bottom, so you could see a nice, just a speaker baffle on that, right? Now, quite often you're going to be required to use something that's called a back box or device box. Quite often they're called back boxes. And just because sometimes you're going to be required up to to comply with the whatever building codes, whatever area you're in. Now, it's quite tempting because those speakers sound much better without those back boxes, because the sound is being transmitted to the other side, and the whole ceiling space can be used as a resonating box. So you get my nice bass if you have a lot of them, right? If just one single speaker, yeah. But if you have like 50 speakers in the ceiling area, then they do sound actually quite nice, right? It's not a hi-fi, but however, sometimes you're going to, and more often than not, you're going to be required to use those back boxes. So the whole thing is enclosed. Right? Oh, here's the last slide. Bang. All right. Now, do we have time? Yes, we do have time to start the second part of the PA system, just two parts. PA system part 2. Let me bring this up here. All right. So this would be the other side of the coin as it comes to, well, the other side of the coin. This coin has more than two sides when it comes to this. All right, let's just get this thing. Public address system part 2 of 2. Well, here is something that I do refer to as the good old rock and roll stage. And some stages are more complex than others. I just happened to find that this photo owned, well, if I'm from somewhere, I'm going to try to look for examples from that place, because I know what's going on, and so I can find pictures that I want. This is New Year's Eve installation for the New Year's Eve in a city that's called Zakopane in Poland. And well, it's becoming quite popular. As far as I'm concerned, this is the capital of New Year's Eve in the whole world, to me, but to you could be somewhere else. All right, so this is what is involved in setting up a stage. Pretty serious undertaking, and a bunch of safety rules, and it's full-blown construction. And it takes about 2 weeks to set this whole thing up or so, and takes, I'm not sure, maybe another week to tear it down. And once it's set up, here it is. Once it's set up, it looks like this. All right. So if you want to look for a job when it comes to being a roadie, if something like that appeals to you, then yeah, but you'll be spending a lot of time outside of your home. Right? Public address, stage, environment. We went over that a little bit last time we saw each other. However, we're going to just go into a little bit more details. Common elements of a stage, live performance, typical stage setup. Now, there are two ways to go about it, and the second way is prying out the first way for the most part. However, we're still in that sort of like a transition time that both systems might be used. However, they're going to be very similar to each other, and you'll know what I mean as I go along here. Here is something that's called a stage box. What stage box has, it has many inputs. Just so you don't have to bring the mixing board right on the stage, because mixing board, where it lives somewhere that is called the front of the house. And front of the house is basically where public is. So you're going to have it in maybe one of those sweet spots right in the public, kind of like, you know, designated area. You see it all the time with some big events. Well, we need to deliver the signal from the stage onto the mixing board. Now, the two ways are, you can go analog way or you can go digital way. The digital way is prying out the analog way, well, because it gets less and less expensive as the time goes along. Well, it's just more practical than the analog. Sorry to say that to all the analog people here, right? It has many inputs and it has some outputs. So the inputs are called the input channels and the outputs are called the returns. So you bring the signal from the instruments, microphones, whatever is on the stage, and that is delivered into the mixing board. If it is an analog setup, you are going to have something that's called a snake. A snake is a multi-pair cable, quite thick actually, and they come in 50-foot lengths, 100 feet lengths, and so on, in order to deliver the signal to the mixing board. But also, some of the signal that is being processed has to be delivered to the amplifier. Now, the amplifiers have to be on the stage or as close to the main output speakers as possible. Why is that? The reason for that is that, let's say the inputs of the mixing board, they could be within the range of more or less, 600 or 800 ohms or 300 ohms or something like that. So it's in the hundreds of ohms. And if you consider the pure resistance of 100-foot cable, you're going to have maybe sometimes 1 ohm, sometimes half an ohm. But it's going to have some resistance because it's a natural way of things. Cables do have resistance. The longer they are, the more resistance a cable is going to have. So 1 or 2 ohms compared to 300 ohms or 600 ohms is going to be quite insignificant. However, if we have speakers that are, well, high power, it could be 4 ohms speakers, then that length of that cable, the resistance of that cable comparing to the input impedance of that speaker, they would be comparable. So for that reason, the signal is being returned from the output of the mixing board, and that signal will have maybe 600 ohms, 800 ohms, 300 ohms, whatever it is specified for. It's going to travel through that wire and it's going to be plugged into the amplifier, and the amplifier output, which is 4 ohms, if it's a high-powered system, then the cable that joins the amplifier and the speaker is not going to have as much resistance as if it's 20 foot long, as if 20 feet long, as if it were 100 feet long. So that's the reason why the amplifiers are on stage. That's if it were an analog system. So there would be the stage box or the distribution box with a bunch of inputs here on the stage, and the mixing board with some effects and processing at the front of the house. If it's a digital system, then you would still have the stage box with many of the inputs, but instead of having many like a snake that has pretty much 3 conductors for every signal, because we're using something that's called a balanced signal, and we'll talk about what balanced signal is later on. It just connects to the mixing amplifier, the digital mixing amplifier, the mixing board, through a Cat5e cable, just like the Ethernet. So much smaller. The advantage of that is that you get to use just one thin Cat5e cable. Let me just check the time, just so I don't go over time here. The disadvantage of the digital, if you can say that, is if that one cable is damaged, well, you gotta get yourself another cable, because all of those channels are done. You know, they're not coming through. If you have an analog, if one channel goes bad, there's some break in the cable, or maybe bad connector or something like that, then that channel is out of commission. All the rest of them are okay. If the Cat5e cable goes bad, or there's a bad connection, then there's some sort of a weird digital signal transmitted to the board, and it sounds actually as just like the biggest lightning storm that you would ever experience. It sounds like skies are falling, and it can actually be damaging to the speakers. So well, just a quick look at that. All right, so that's pretty much as far as just a general overview of the stage setup. What else do we have here? We have some monitor speakers. So these will be front of the house speakers, low range and mid-high range. That will be the speakers that convey the sound to the public. And this will be the monitor speakers. These are the monitor wedges. So it's standing on the floor in front of the artist, so the artist can hear what he or she is singing, or can hear other instruments. And there will be a separate front of the house mix, so the sound levels are adjusted properly for the public to hear. And there also would be a separate monitor mix, so the artist can hear certain instruments louder, certain instruments not as loud, to their comfort for performance on the stage. Sometimes monitor speakers are being used, and sometimes something that's called in-ear monitors. So when you see some of the artists performing on big stages, you're going to see some sort of like different devices plugged into their ear. That's so-called in-ear monitor. So you don't need those stage monitors. And also there will be a separate audio mix for those in-ear monitors, and they are molded personally to the person's ear, and fitted with the circuitry and the headphone kind of a circuitry. And they are supposed to be designed in a way that once you plug them into your ear, it blocks out all the sound, and the only thing that you hear is the sound coming from those in-ear monitors. So obviously there's a separate audio engineer that will be sitting and another one of those and sending the proper monitor mix to all the artists. All right. Here's an example of a small mixing board. This is a small mixing board. I'm just going to go quickly over the, most of us have done some sort of a sound system setup already, maybe in high school or whatnot. Well, here are strips. This one has 2, microphone/line strips, channel 1, channel 2. Channel 1 and 2 are equipped with something that's called XLR, balanced signal inputs. So you can plug in a microphone, low-level signal. It's within the range of 1 millivolt peak to peak. And Or you could plug into the line level inputs, or you over here, but you could switch the selector switch for that one here, for this input. So if you want to have the signal, it's line level or a microphone level. Microphone level will be in the range of 1 millivolt peak to peak, and the line level would be in the range of 1 volt peak to peak. Now, microphone levels usually are from the passive devices, such as dynamic microphone. However, the condenser microphones also are adjusted, so they transmit that level of a signal. Even though it's not a passive circuit. A passive circuit is basically on its own, and an active circuit would be some circuit that requires some sort of power from maybe a battery or external power, such as electronic keyboard is an active device because it needs to be plugged into the wall, and it has all kinds of electronic circuitry inside and is capable of transmitting a stronger signal. Whereas the dynamic microphone, it just has the membrane that vibrates, and that creates the electric pulses through the wires. So obviously it's not going to be that strong of a signal. Right? So there are two strips here, and there are additional line. There's additional line strip, so it's channel 3 and 4, and most of the mixing boards would have some sort of control over the signal. So here's the gain stage of that. Depending, because different instruments have different signal strength, it would adjust the gain comfortably, so the volume of that strip can be adjusted comfortably for the rest, comparing to the rest of the channels, and then you would have a little tiny bit, sometimes more complicated, sometimes less, a little bit of like a strip, just like equalizer just to apply to that strip. And you can send that signal also to an auxiliary output, which would be just like one more output. And you can use that auxiliary output for, let's say, you can send part of the signal to the monitor mix or some other outputs, routes for the signal. And some of them have a little bit of effect that you can apply. And here, in this case, this would be this knob here. You have to figure out every mixing board that you're going to get, because they have slightly different arrangements of the knobs and buttons and whatnot. And in this particular one, there's a little bit of a main output equalizer, like a graphic equalizer, so you can adjust the sound levels coming out. Right? And they will have other inputs and outputs, tape in, tape out. Well, we don't use tape, but the terminology has stayed. So you could record it onto a tape recorder, or you can play it back from tape recorder, some sounds. And over here, you can see headphone output and main volume right there. Right? All right, so that's the main. I just chose that small mixing board. You can buy that kind of thing online or in the store, music store, for about maybe $100 or so. Now, we just explained those inputs and outputs. So this is just a magnification of this area right here. So we just went over that. So I'm going to skip through those slides. We're getting close to the time here. Now, some of them bigger mixing boards are just like the small mixing boards, but they're bigger. Instead of 1 or 2 channels, if you know how to use 1 channel of that, then you know how to use the rest 23 channels, because this one is 24 channel, considered to be 24, well, maybe 32 or 30 channels. Well, something like that, 30 channels. So, so you know how to use the rest of them. So the bigger mixing board just has more channels, and the main part, it might also have some groups. Right? So you can group some of the channels, like let's say, for example, if you're miking the drum set, which would be about 6 to 8 microphones, You can adjust the volume of each microphone that is applied to the drum set. You can establish proper balance of those microphones, and then you can assign them to one of the groups. So if you want to raise the volume or lower the volume of just the drums, you can have one knob just to do that. It's a convenient thing. Just an example of why the groups are being used. It just has more inputs and more outputs, but the idea of how to work it is the same as the small mixing board, right? So that would be this would be an example of an old analog mixing board, which would employ a snake in order to provide the signals and the returns to the stage box. Right? Now, here's an example of, well, very expensive digital board. Now, the digital boards, some of them are as expensive as this Yamaha CL5, which is pretty much the industry standard for big shows. I'm not going to tell you how much it costs. However, if you check this out, you're going to go, wow. You can buy a pretty good car for this mixing board. Now, the digital mixing boards, this could be a mixing board that has many, 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 many channels, but you don't have as many knobs as the channels. An analog system here, every channel has a physical knob assigned to it, and you can see them all the time, and you can touch any one of those physically at any time. Now, when it comes to the digital mixing board, you have channel ranges. So this here LCD, come on, is going to display 1, 2, 3, 4, 5, 6, 7, 8 channels at a time. So let's say display channel 1 through 8. And those knobs are going to be assigned through channel 1 through 8. Now you can flip that and you can shift the display from channel 9 to 15, right? Then, or 16. Then those knobs are going to operate channels 9 through 16, and they have internal motors that they're going to, once you switch the view, those volumes, they're going to automatically move. So you can, and they have, those digital boards have all kinds of effects and plugins built in. Also, the advantage of this thing, because it's a digital thing, if you are a roadie that is servicing one band all the time, then if you do one sound check on one of the stages, you will know pretty much the balance of who needs more volume, who needs less, who needs some effects applied and who doesn't. And you know what? You can save that onto a file. And you can save that onto a jump drive. Just a stick. You can hold it in your pocket. And then when you're traveling, some of the serious shows, they don't travel with their own mixing board. They just request that this thing is available for them. The setup is available. So the sound engineer just goes with the jump drive, plugs it into this mixing board, and recreates all the sound checks, now you might have to adjust it because slightly, because it's a different room, different venue or whatnot. So you may have to do some slight adjustments, but you're not going to have to do those extensive sound checks every time you go into a different room and set things up. So technology goes a little bit. So this looks pretty similar to digital audio workstations like FL Studio. Yeah, there are many different ones. Behringer is one of them that has pretty good stuff as well. Now, as far as stage setup, quite often you're not going to use any of the cabling, signal cabling. Everything, the stage box is plugged in on the stage, and you would have, through Bluetooth or otherwise wireless, control devices that you could set up somewhere else at the front of the house, and you can control those devices wirelessly. So that's quite convenient, quite convenient way of doing that. Yes, Behringer has one of those things. I think it's XR16 or XR18, something like that, that you can use your tablets and whatnot to just go and to adjust that. So technology has evolved over the last few years quite a bit, actually, right? Right, you know what? Yeah, it's we got 5 minutes, and you still have to have some time to get to your next or get ready for your next class. And I have another class an hour from now, which means I have to prepare and drive to the college because that class is in person. So we're going to stop right now. Now, this usually when I post these videos on YouTube, you get them right away within about 15-20 minutes. The video is on. However, this one I'm going to post later on at night when I come back from the college. Okay. All right, guys and gals. Nice to not see you because you can see me. I'm not seeing you. And I will see you next time we have a class in person. And this is Mr. Barks signing out. Thank you very much. Always have to look for the buttons. And sometimes they work and sometimes they don't. Oh, I'm going to press this one, see what happens.